Good morning and good afternoon to all our Stir Shaken webinar participants in Western and Eastern Canada, respectively. My name is Ron Aharoni, and I'm the moderator of the webinar today. We are delighted to have you on board, and thank you for taking the time. This is also the right time to point out that we have no intention of serving any martinis, either stirred or shaken, during this webinar. A few words about our company, COMsolve. Founded in 2006, COMsolve is a Canadian leading-edge information and communication technology solution provider. We are involved in a number of Canadian telecommunication industry initiatives, including as an active participant in CISC activities related to the nuisance call traceback trial TIF38 as a working group chair, and Stir Shaken TIF40 as a working group co-chair. Additionally, COMsolve, in partnership with NetNumber, is actively assisting Canadian TSPs get ready for Stir Shaken. The public switch telephone network, PSTN, and its end users continue to be plagued by unsolicited calls, some of which are fraudulent and which can lead to financial losses and little to no recourse. In some cases, these calls also have fake or spoofed calling line numbers designed to entice users to answer these calls. The Stir Shaken framework won't stop fraudsters from using the phones to perpetrate their activities, but it will eventually provide some trust that the calling line ID is not fake and can assist in after-the-event call traceback by authorities. A few words about today's speaker. Ed Antecol is COMsolve VP of Professional Services and Legal Counsel. Ed has over 35 years experience in the telecommunication industry. Prior to joining COMsolve, Ed worked as VP Carrier Services and Regulatory at Global Live and Freedom Mobile for about 10 years, where he was actively involved in implementing many CRTC mandated service capabilities, including in E911, local number portability, roaming, and carrier interconnections. He is actively involved in supporting our clients' efforts to get ready for Stir Shaken. Ed's bio can be found on COMsolve website. The webinar format: during the 1-hour webinar, we would conduct 3 brief polls to get a better understanding about the state of Stir Shaken in your specific segments. We would greatly appreciate you taking a few seconds to respond. We have also allocated time for Q&A session where you can submit your questions through the text feature of GoToMeeting. At this point, I will hand off to Ed, who will be conducting the presentation. Thank you.
Thank you, Ron, for that introduction. My name is Ed Antecol, and I'm today's presenter. My presentation is divided into 3 portions today. Part 1 is dealing with regulation and obtaining a call signing certificate. Part 2 deals with actual call signing and authentication services. And Part 3 deals with call verification by the terminating carrier. So what is Stir Shaken? Well, it's an acronym, and it stands for Secure Telephone Identity Revisited / Signature-Based Handling of Asserted Information Using Tokens. So probably doesn't mean a lot to most folks unless they're immersed in RFCs and ATIS specifications, but that's what it stands for. Its purpose is to reduce fraudulent spoofed caller ID telephone calls to consumers and to assist with call traceback. Stir Shaken is a set of protocols and procedures for the secure transfer of information about the caller ID trust level and other information from an originating carrier to a terminating carrier. The passport is encrypted with the originating carrier's secret private key, and hence you see the expression signed password. The originating carrier's public key is used to decrypt the passport at the terminating provider. The passport contains 3 key pieces of information. Information as to the identity of the signing carrier, the caller ID trust level, and when I say caller ID, some people refer to it as calling line ID, but I just using caller ID for short, trust level, and I'll get into what those trust levels are later in the presentation, and an origination ID value, which is to aid with call traceback after the call has ended. So the most recent CRTC decision on STIR/SHAKEN is CRTC 2021-123, released April 6th, 2021. In that decision, all telecommunication service providers, or TSPs for short, must implement STIR/SHAKEN, i.e. authenticate and validate IP-based voice calls by the 30th of November, 2021. And the CRTC's authority for that regulation or that rule is Section 24 and 24.1 of the Telecommunications Act. In addition, TSPs must file a STIR/SHAKEN implementation readiness assessment report by the 31st of August 2021, as well as subsequent reports. And the CRTC decision itself contains an appendix which outlines the details of the reports that TSPs must file. The obligation on TSPs to implement STIR/SHAKEN applies only to IP-based voiced calls. However, the CRTC decision provides further clarification on the matter. And I'm quoting from the decision, the requirement to implement STIR/SHAKEN, quote, applies to calls that travel over a TSP's IP-based network, including any portion of its network that is able to initiate, transit, or terminate IP-based calls. So it's clear that the obligation is not limited to IP-based end-to-end calls made to handsets or other devices that are able to receive and or transmit STIR/SHAKEN or SIP messages. There will be further clarification as to what needs to be implemented by November 30th when the NTWG TIP 40 completes its work and files an implementation guideline. Hopefully this presentation can help you understand what needs to be implemented and where it needs to be implemented. So to begin the process, you need to get a STIR/SHAKEN certificate. And you need that certificate in order to sign calls and create the passports to terminating carriers. So it's the first step in participating in the Canadian ecosystem. To begin the process, you have to register with a group called the CSTGA, which is the governance authority for the Canadian STIR/SHAKEN ecosystem. Eligibility consists of all LECs, CLECs, wireless service providers, and those service providers that have direct access to Canadian numbering resources or are eligible to get such access. So therefore, as I understand it, eligibility includes Type 3 and Type 4 CLECs. Local VoIP providers and other resellers, however, as of now are not eligible to apply to the CSTGA and become part of the STIR/SHAKEN ecosystem. There is a Part 1 before the Commission, and we expect a decision soon, and that will determine the eligibility of local VoIP providers and other resellers to join. If you want to find out if your company is specifically eligible to join the ecosystem, I've got a link here on the presentation, and you can go to that link and fill out the form and find out.
Thank you, Ed. At this point, this is our first quick poll. I would greatly appreciate if you take a few seconds to provide your feedback. Thank you. Thanks very much.
Okay, so the next step in the process, once you've joined CSTGA, is to establish an account with the policy administrator and the certificate administrator. In today's environment, the policy administrator and the certificate authority is one company. But in the future, and in the US, for example, there's one policy administrator and there's multiple certificate authorities. There's 5 to choose from, and some carriers have decided to become their own certificate authority as well. So in Canada, hopefully we'll see more CAs to choose from, but for immediate implementation purposes, you'll need to establish an account with the PA so that you can receive a token to get a certificate and an account with the certificate authority so that you can get your identity certificate so you can sign calls. Once you've done that, the next step is to determine how you will interface with both the PA and the CA, because there are electronic interfaces in place to get your token and to get your certificate. So one of the things you need to think about is, do your own carrier systems support the automated certificate management environment protocol, known as ACME, and it's set out in RFC 8555, or will you be preparing a certificate signing request directly on your selected server and performing certain parts of the process manually to get a call signing certificate properly installed? So you need to think about how you're going to do that. And one word of caution, you will need to prove certain technical capabilities before you'll be issued your certificate. So as you go through the process, you will be challenged to prove that you're technically able to get the token and the certificate securely. So the next slide here shows the overall architecture and functional elements for getting a call signing certificate. The box on the top left is the policy authority, and it is funded by the industry. So when you join CSTGA, you will be subject to paying fees and funding the policy administrator. The next box on the top row is your certificate authority. Your certificate authority may or may not charge you a fee for an annual fee for your certificate. And then the next 3 green boxes in the middle level, and that is the secure key storage, the SKS function, the KMS function, the key management server, and the CR, the certificate repository. Those 3 functions are what you have to put in place in order to get your certificate from the certificate authority. And then the bottom 2 boxes I'll be discussing later on in the presentation concern the authentication service and the verification service that you will transact with on a per call basis. But right now we're focused on getting the certificate from the CA. And so if we can go to the next slide. I'm just going to go quickly through the process, and I've simplified the diagram just a little bit, but I'll take you through the process briefly. So you start with a server that you will dedicate for STIR/SHAKEN, and on that server you will need to create a public-private key pair. And then that's the starting point, and then your next step is to apply to the policy authority for a token. Okay, and they will send you something called an SPC token, and you only need one certificate as a service provider. So if you have multiple OCNs, you can just pick one of the OCNs and get a token for that OCN and subsequently a certificate. But you could choose to get more than one certificate as well if you find a need to divide up your network. Okay. And this architecture exists in part in order to give the policy authority the ability to revoke certificates and to know who has certificates. So it's an essential part of the overall architecture. So you then get your token back, and then the next step is to apply for a certificate from the CA. And you do that by creating a certificate signing request and include in that request your public key, and you send it up to the certificate authority. It will challenge you and ask you for the token, and it will also go back to the PA to make sure you're eligible to have a certificate in step 3 and step 4, and then in step 5. And then in step 5, your certificate will be returned to you. It'll be a signed PKI type certificate. Embedded in it will be your public key. And at this point, you're in a position to sign calls. Your key management server will also need to push the private key, which you have to keep absolutely secret, because if someone else gets your private key, they'll be able to spoof you as a service provider, and you'll have to rekey your certificate or get a new one. So you'll have to securely store your private key and have it accessible by your authentication service. And lastly, you'll need to store your public certificate in a certificate repository so that terminating carriers can retrieve that certificate, make sure the certificate and your identity is valid, and retrieve the public key so it can validate the signature on your passport that you've signed with your private key. On this next slide, and this is taken right out of the ATIS spec 10074, is the reference call flow. So we'll start from the bottom left-hand corner, and in here you have the your SIP user agent within your network that represents the user, the authenticated user on your network. That user agent will generate the SIP invite to your call session control function and in your network, and then it will then pass that up to, you will then pass that up to an authentication service, and we'll get into that in more detail. The authentication service will in most cases produce a passport for you to include in the SIP invite as an identity header. You will then send that SIP invite to the edge of your network to an interconnect border control function, which is typically your routers and your firewall. It's the outside point of your network used to interconnect with other carriers. You'll send the SIP invite along to the terminating carrier, who will then, that call will then be forwarded to the call session control function of the terminating carrier. It will extract the passport, send it to a verification service. You'll get a result back from the verification, and then you'll eventually terminate the call at the user, and you may or may not display the results, and we'll get into that in more detail of the stir shaken validation. So I'm now in this next slide going to go in more detail over the authentication process. So on this slide, I've skipped the user agent. So it's a simplified call flow. The call comes in from the bottom left. The user agent represents the authenticated user on the service provider's network. Your call session control function represents a function which takes care of, is the SIP registrar and is the routing function in your network. It also should contain a SIP application server interface to interface with the authentication service, but we'll get into some variations on that. Now, one of the more important details on this slide is the reference to ATIS 10082. So there is a defined protocol for your call processing to use with an authentication service. So, and I'll go into the details of that, and it's referred to again as 10082. If your switch supports, or your session border controller, or whatever element contains your SIP application server interface, if it supports 10082, you're ready for stir shaken. All you need to do is add an authentication service, or you buy it from a cloud-based provider or some other provider, but you can buy an off-the-shelf authentication service, either monthly or one time, however you want to do it, and then you're in a position to implement stir shaken and sign calls. If you're, and I'll in the next couple slides, I'll talk about, well, what if your network doesn't support 10082? What are your alternatives? But if you want a very quick method to determine whether you're going to have an easier time of implementing stir shaken, check with your switch and your platform provider and ask them if they support 10082. So you send the signing request up to your authentication service. What comes back is the passport in the form of an identity header. You add it to the SIP invite, and then in step 7, you send it to your interconnection border control function, and that gets sent off to the terminating service provider.
Okay, thanks, Ed. At this point, I would appreciate once again if you take a few seconds to respond to the second poll. Thank you. Okay, thank you very much.
So in this next slide, I'm showing an alternative if your session border controller or your switch doesn't support 10082, but does support a SIP redirect. So in this example, the SIP invite comes into your session border controller. You then send a SIP invite without the passport to the authentication service, and it will return the SIP invite in the form of a SIP message with the passport already embedded as an identity header in the SIP invite, and then you redirect that SIP invite back out your network to the terminating service provider. So in this example, we're not using 1082. We're not sending the passport parameters to the authentication service. Instead, we're sending the SIP invite and asking the authentication service to add the passport to the SIP invite. So it is an alternative, and there are other alternatives as well. You can add another server inline in your call processing flow to implement the gateway to the authentication service and then populate the SIP invite. So there are alternatives, but it certainly is a lot easier if your switch supports 10082. So, a couple of key pieces of information, as I mentioned before, are contained in the passport. One is an attestation level about the caller ID, about the trust level in the caller ID, and the second one was the origination ID. Well, there are three values for the caller ID attestation. The first one is an A. Okay, and here are the conditions for which you can give an A. And by the way, if you give it an A, then depending on the end user device at the terminating carrier, and depending on what the terminating carrier state of implementation is, the user will experience a green check mark near or beside the calling line ID. So if you want, and most customers I think will want this, will want their phone number to be trusted, so they'll want a green check mark to appear visible to the party they're calling. But these are the conditions that you as an originating carrier must meet in order to give that call that A-level attestation. You as the service provider have to be the one responsible for the origination of the call onto the IP-based service provider voice network. So if the call came from another carrier, you're passing through the passport. But if the call came from another carrier and the call didn't originate on your network and there was no passport, you can't give it an A. Second thing, you as the service provider have to have a direct authenticated relationship with the customer and identify the customer. So if there ever is a traceback investigation by authorities and someone comes to you and says, we're investigating this call and you gave it an A, so you must know the identity of the customer, you'd better know the identity of that customer because if you don't and you've given it an A attestation, your reputation will be mud, and we're not sure what the consequences will be, but in the States you can have your certificate revoked and your ability to sign calls revoked if you give false attestations. So you have to know who the customer is that's originating the call in your network, and you also have to know that the customer is entitled to use the phone number that's being displayed. Okay, now that can come through a number of different mechanisms. We'll talk a little bit more about that later. But if you as the carrier are the one that populates the calling line ID, then of course you know there's a verified association with the telephone number used for the call. Similarly, if you rely on information in the SIM card, if you're a wireless carrier and you know the user can't alter the calling line ID that's displayed, then you can give it an A as well, because you know there's a verified association between the number and the caller. But where you can't verify that association, it doesn't qualify for an A. B level is the next trust level, and this is where the service provider is still responsible for the origination of the call onto its IP voice network. The service provider has to have a direct authenticated relationship with the customer and can identify the customer, but the service provider has not established a verified association with the telephone number being used for the call. Most common situation is an enterprise customer, where the enterprise customer can set whatever calling line ID they want on the outbound call, and because they can put whatever number they want, you as the service provider won't know whether that customer is entitled to use the telephone number that they're presenting as the originating calling line ID. But if you do put a B, it says you know the customer where that call came from, and if there's ever a traceback request that comes your way as the originating provider, if you've attested B, you should know who that customer is. And the last level of attestation is when the call comes in and you don't know the customer, and you don't know that that customer is entitled, obviously, to use the phone number that they're displaying. It's most typically referred to as a gateway attestation. You will normally do this when you have incoming calls that come in on TDM trunks where there is no passport, or that come in on a SIP network-to-network interface between service providers, and there is no passport. And it indicates that you have no relationship with the initiator of the call, but you do know what interface it came from, or what provider or what network interface the call came in on. And that too can be useful for traceback, because the people doing the traceback can say, okay, well, it came in from the network interface from carrier XYZ, and so they can then go to carrier XYZ and continue the traceback hunt. So the second key piece of information in the passport is something called OrigID or origination ID. And it's a piece of information that's added in the passport to assist with call traceback. The OrigID is a number that's assigned by the originating service provider. And there's a number of rules and guidelines, and they're a little bit in flux. The specification has been updated once already. So these are more guidelines than they are mandates. But I'll take you through the thinking behind how you set your origination ID. Where the customer cannot modify the calling line ID, the origination ID must be a unique value to assist call traceback with the originating service in the originating service provider's network. So as long as it's unique, and it could be a timestamp plus the IP address of your switch, for example. So it will be unique, and you can use that to find the call records, and that's all it really needs to be. Where the customer can modify the calling line ID at the user network interface, where it comes into your network, the guidance is it would be helpful if the origination ID is persistent and opaquely associated with a customer or a customer UNI. The problem there is that you will also be passing information in the passport to analytics engines, such as the trust level or attestation A, B, or C, as well as the OrigID. So you have to be careful if you're associating the OrigID, even if it's opaque, with a specific customer, that you're not giving these analytics engines additional private information. So while it's nice that OrigID is associated with a particular UNI, if it's a small customer or an individual, you'll need to consult with your chief privacy officer to figure out whether in fact the OrigID can be unique across all the phone numbers used by that customer, and it may not be appropriate in many circumstances. Where the call is received over an NNI without an identity header, the service provider should have a persistent, permanently assigned OrigID value that's at the granularity of your peer service provider or the peer NNI. So the OrigID would be traceable to where the call came from and entered your network. So now I'm just going to present some examples here of 10,082 and what you would need to do at your call session control function. And essentially, it's a JSON procedural call, and essentially it looks just like I've shown in this example that I've taken right out of the 10,082 spec. It's a signing request. you populate the attestation level that you figured out, the originating telephone number, the destination telephone number, a timestamp, and an origination ID. And you just send those values up to the authentication service, and then back should come the signed passport. And in this slide, I've again taken straight out of the 10,082 spec is the response to the signing request. And in orange is the identity header, which is your passport. And just one thing to note, it is encoded, and there is a cryptographic signature in the passport, as well as there is a link, and you can see that at the bottom of the identity header in the orange. There is a link of where the terminating service provider should go in order to get your STIR/SHAKEN PKI certificate, and embedded in that certificate is your private key. Now, many carriers will cache these certificates so they don't have to go over the internet to a certificate repository to grab your public certificate. But if it's not cached, or if you need to refresh your cache, each passport will contain a link about where to find the identity certificate of the originating service provider.
Thank you, Ed. This is our third and final poll, and once again, I would appreciate if you take a few seconds to provide your feedback to this poll. Thank you. Thanks very much.
Okay, I'm now shifting gears to the third and final part of my presentation, and I'm going to be talking about call verification by the terminating service provider. And this diagram that I've got up in front of you is the call flow, and we'll start just from the bottom left, where the SIP invite comes into your call session control function. Again, you would do a JSON 10,082 call where you send the validation request up to your verification service. Your verification service goes and gets the certificate that's in the passport, referenced in the passport, and again, it could be cached or it could be at a certificate repository. You get it. You use the public key to, and we'll talk a bit more in a minute. You use the public key to validate the passport, and then what you can do is, and this is optional and not part of the STIR/SHAKEN specification, you can pass it to a call validation treatment or to your analytics, because your analytics may want to override the STIR/SHAKEN attestation because it may have more information. But then ultimately your verification service will then send a response back to your call session control function, and your call session control function will then be able to terminate the call again through your network, ultimately to the end user. And depending on the end user device and depending on what's sent, what the Veristat value is and what you've decided as a policy matter, the user may or may not see a green check mark on their call display on their phone. So this next slide talks about the two main functions that you perform in verification. So the first thing is you retrieve the originating service provider's certificate referenced in the X5U field in the passport. You check its validity, and you check a certificate revocation list maintained by the policy authority. And if the certificate appears in the certificate revocation list, then you treat the passport as indicating a verification failure. So your verification service, and I've just drawn out a couple of the error codes. I refer you to 10,082 for all the additional reason codes. But your verification service might return a 436, which indicates that it can't dereference the link to retrieve the originating service provider certificate. Or it could return a 437, which suggests that you can't trust the public certificate that was referenced in the passport. Then you look in the passport once you've validated that you can trust the certificate, and you look at things like the date, because embedded in the passport is a timestamp date, referred to as IAT. And if that date is an old date compared to the current time, then you've got a stale date, and perhaps you've got a replay attack where someone's captured some packets and keeps sending them over and over again. But you would generate an error 403 in that case. And you'd look at the signature, the cryptographic signature. You'd use the public key to decode the signature, which was encoded with this originating service provider's private key. And therefore, if you can't validate the signature, you'd return an error 438, invalid identity header. So those are the two main functions of the verification service. And here I've just drawn from the spec. This is how you, using 1082. This is how you would request a verification of a passport. You'd provide the from telephone number from the SIP invite, the to number from the SIP invite, the current time, and the passport, which is which is referred to as identity on this slide. Pass that information up to the verification service. And here's an example of two responses you might get back. The key piece of information that you get back is a veristat value, and there are only 3 possible veristat values, and I'll be talking about those in a moment. But if the verification was successful and the telephone number validates, in other words, if it's an A-level attestation, you're going to get back a veristat value, TN validation passed. If you are able to validate the passport, but you can't validate, or if you can't validate the passport, or if there's something wrong, you will get back an error message, you'll get back an error reason, and you'll get back a veristat value. So for the full set of responses, again, I'll refer you to the actual specification. So again, the verification service results are conveyed through a veristat parameter. The veristat values are TN validation passed, TN validation failed, and no TN validation. The service provider can pass the veristat value to end user equipment and/or pass the value to an analytics engine. Only A-level attestations get TN validation passed. Some wireless devices, and I have to say some non-wireless devices, some SIP clients, will support the display of a veristat parameter, while others will not. For TN validation passed, capable wireless phones will display a green check mark beside the caller ID. And that is also true for certain SIP clients, non-wireless SIP clients. Analytics, if used, may augment the stir-shaken results. Analytics could flag possible fraud, while stir-shaken by itself, while examining the same call, indicates TN validation passed. This is because analytics relies on multiple inputs, including the stir-shaken verification service result, to execute an algorithm to advise the called party of the integrity of the caller ID. Current initial recommended display strategy is set out in the next slide. This slide was taken from an NTWG recommendation in TIF 40, And what it suggests, at least for the initial implementation of STIR/SHAKEN, and this can be this will change as STIR/SHAKEN is deployed more and more, and users get used to seeing the green check mark. So there will be an evolution of this table. But as it stands now, the recommendation is if it's an A-level attestation and there's no analytics and it passes the verification, then you should send the TN validation passed Veristat value to the device or the terminating SIP client. And if the device is capable, it will display the green check mark. If it's an A-level attestation and verification fails, the recommendation is don't send a Veristat value to the phone. And if no verification is performed, also don't send a Veristat value to the phone. Just let the phone display what it normally displays. Similarly, for B and C level attestations, they're saying don't send. The initial recommendation is don't send a Veristat value to the phone. Let the phone display the call as normal. And then in all cases, if you have an analytics engine, carriers are free to augment or change what is displayed based on the results of their analytics engine. So the recommendation isn't really saying anything about how analytics engines should perform, how they should behave, or what they should display. So that brings me to the end of my presentation. But one thing that I would like to note very briefly is that COMsolve has partnered with NetNumber to assist carriers in implementing STIR/SHAKEN. They have a product called Guaranteed Caller, which makes implementation of STIR/SHAKEN easy. It's a cloud-based service, and it contains all of the elements that you need to support STIR/SHAKEN. So it includes the key management server, secure key storage, the certificate repository, an authentication service that supports 1082 and SIP redirects, and a verification service that supports 1082. And it is 100% compliant with the Canadian requirements for implementation of STIR/SHAKEN. And it supports the full registration for the certificates. You fill out the paperwork and the contracts with the CA and the PA and the CSTGA, but it supports all of the electronic interfaces necessary to get and install your certificate. And that's it for my presentation. I think we'll go to questions now.
Excellent. Thank you very much, Ed. We have a long list of questions, so let's jump right into it. The first question is, my network has only one SIP connection to another carrier. Most of my traffic is to and from the ILAC using TDM. Only 2% of my traffic exits my network over SIP trunks. Do I need to implement STIR/SHAKEN?
Yes, you do. The CRTC has clarified that in the last decision. If you look at it from a public perspective, if people didn't have to implement STIR/SHAKEN until their network was fully SIP implemented and all their interconnections were SIP-based, then we'd be several decades away from implementing STIR/SHAKEN. So the CRTC's view, as expressed in their decision, is that if any part of your network is SIP-based, then you need to support STIR/SHAKEN for that portion of your network.
Thank you. The second question is, I have no wireless customers on my network. I therefore have no means of displaying a green check mark to my customers. Can I skip the verification of incoming SIP calls from other carriers?
No, unfortunately you can't. And there's two reasons. One is by doing the verification on the incoming call that has a passport, you're able to keep track of the origination ID and the attestation level in a log. And so if there's ever a traceback request, you can go back to that log and you can see what the origination ID and the asserted trust level on that caller line ID is. And that can be very useful for call traceback. So if you simply throw away the passports and there's a request for a traceback, you've made the process more difficult. And the second reason why you can't just throw away the passports and ignore the verification is that it's not only the wireless handsets that display the green check mark. As time goes on, more and more SIP clients and new phones will also be able, SIP-based phones will also be able to display that green check mark. So you can't make an assumption if you're sending the call, if you're terminating the call via SIP to a handset or a phone, you can't make the assumption that there's nothing for that handset to display.
Thank you, Ed. The third question is, how do I support getting enterprise customers to an A level in the STIR/SHAKEN ecosystem, as only the A's will get the gold seal green check mark?
Well, there's a number of ways you can get your enterprise customers to an A-level attestation. First of all, not all enterprise customers are able or are freely able to set their calling line ID. In many instances, it's the originating service provider that has control over the user agent and sets the calling line ID. So if your network is configured vis-a-vis that customer user network interface to automatically populate the calling line ID based on that carrier's provisioning, then you can give that enterprise an A-level attestation because that customer, you know by default, because you're setting the value that that customer is authorized to use that calling line ID. Another option is for you to work with your enterprise customer and get a list of calling line IDs that they're going to display. So if they're an outbound calls contact center and they're representing several doctors' offices or several schools or whatever, and they've got several different calling line IDs, get the list. And if you can nail that customer down via contract, such that the customer promises to only use those calling line IDs and can prove that they're authorized to use those calling line IDs, then you can rely on your enterprise customer your enterprise customer's promise to only use those, and you could see your way clear through contract to perhaps giving them an A. But when you do that, you put your reputation on the line. So if your customer cheats or violates their contract and starts putting calling line IDs that they're not authorized to use, in other words, the call center turns from a legitimate call center to one that's a little bit shady, then you've got a problem, because if you're automatically giving calls on that user network interface an A-level attestation, you're putting your reputation on the line, and you risk your own certificate and your own participation in STIR/SHAKEN, which could impact the entirety of your customer base. So another way you can get them to an A is through knowing your customer really well and through contract with your customer and creating a whitelist for that user network interface. A third way to do that, and there are a number of other ways as well, is to deploy a mechanism called delegated certificates, where the customer directly or indirectly provides you its own attestation about the calling line ID that's been verified by a third party, and you accept those delegated certificates and you use them to generate your own STIR/SHAKEN certificates that you send on to terminating providers. There are standards for these delegated certificates, but there's no one standard that every carrier is going to use for delegated certificates. They may choose other methods instead of delegated certificates. So you're a little bit on your own in terms of choosing how you're going to deal with your enterprise customers who insist on getting an A and want the flexibility to change their calling line ID display as they wish.
Thank you, Ed. And here we have a question that probably reflects the mood of many participants. What will the CRTC do if I'm not ready for stir shaken?
Well, I'm not the CRTC, so I can't say for sure what they're going to do. But I will make the following points. One is the CRTC does have an authority to levy administrative monetary penalties on service providers who don't comply with their rules. I'm not saying that November 30 they're going to start applying penalties right away to non-compliant carriers, but I think longer term they do have that ability. The CRTC also has an ability to call service providers in for a meeting to discuss less than optimal behavior, and they also have the ability to require service providers to provide reports more frequently and provide updates and plans to become compliant. So at the end of the day, I suspect the CRTC will start ramping up pressure on non-compliant carriers to provide deadlines and implementation plans if they're not already in compliance. And there is always that possibility of penalties, and I can't tell you if and when those would get applied. I think that's the best I can do on that answer.
Thank you, Ed. We are almost at the final minute of the hour, so maybe the last quick question. I work for an outbound contact center where we call customers to remind them of doctor appointment and service appointment. We have an obligation to display a contact number which varies by client. Is my carrier required to support a mechanism whereby my legitimate calls are not labeled as spam and that such call receive a green check mark when it can be displayed by the calling party?
So the quick answer is there's no direct requirement. Obviously, your carrier will want to keep you happy as a customer, and as a customer, you should demand that your carrier provide a support mechanism. And as a contact center, if you can validate entitlement to a number, then there's no reason why your carrier shouldn't work with you to provide that A-level attestation.
Great, thank you very much. We will try to answer all your submitted questions through emails. I apologize, but the hour went by so quickly, so we'll try to communicate with each one of you through email and provide you with the answers that you were looking for. And we are already working on our next seminar, next webinar, and hopefully we will see you again. And when you log off properly from this current webinar, I would greatly appreciate if you take a few seconds to respond to the survey about this webinar. There are 3 questions, so your feedback would be greatly appreciated. Thank you very much and have a great day, and thank you for participating.